made a revisit of C programming language. We have recapitulated the concepts, the common concepts in C, and made sure that we are prepared to slowly get familiar with C++. In this module and in the next 3 modules, we will talk about various programming examples and show how in C++ these programs can be written more efficiently, more elegantly, and often with better ease than what is needed in C. So, in module 2 we will get started with understanding the basic differences between C and C++ programs, and we will try to appreciate the ease of programming in C++ as we go over this module as well as the following 3 modules. We will primarily talk about the contrast in the areas of I/O, variables, math library, standard library headers, loop and the bool type. So, we start with the same initial program in C, that is to print hello world. So, here in 2 columns we show the program to print hello world in C as well as in C++. You can note some of the basic differences. First is the I/O header has changed. In C it was stdio.h, in C++ it becomes I/O stream. In C when we do printf, we write to console, we print to console. Here we use an operator, a pair of left arrow operators called the output streaming operator to stream to control, and the console was std out file in C. Now, it is a C out stream in C++. Also note that we are using a prefix before C out, that is called std, and it is written with std::. This notation we will get used to quickly. This std is called a namespace, the standard namespace. So, any standard library symbol in C++ will be prefixed with this particular prefix string std. Now, another major point to note in this simple hello world program is when we do printf, we can have arbitrary number of parameters. We call this a variadic function. So, here in the hello world example, we are seeing 2 use of printf, both of which use one parameter, the format string. Of course, we do not have a format here, it is a constant string being printed. In contrast, in C++, the output streaming operator is a binary operator which has the stream on the left hand side and the content to print on the right hand side, and it prints in this form. So, if we look at the first output line std::cout output operator, and within double quotes we have a constant string, it means that the hello world in C++ string will be streamed to the console C out. Also note that the new line character, which was a escape character \n in C, the same can be used, but there is another way to go to new line, that is called endl, which is a short form of end line, and we will learn later on that endl is basically a stream manipulator. So, just we are trying to observe that the basic output system in C++ program can be done using C out and the output streaming operator. We move to the next program, where we are illustrating a very simple arithmetic program which has 2 variables a and b and adds them to generate their sum. The values of these variables are read from the console again, which in C is std in and we use the scanf function, which all of you are familiar with the format string. Scanf, like printf, is a variadic function, that is, it takes variable number of parameters. Here we see a form of scanf which is taking 3 parameters, the format string and the addresses of A and B respectively. In contrast, in C++ program, we introduce another operator which is used for streaming from an input stream. So, this is called an input streaming operator. It is again a pair of arrows, but the arrows now direct in the left, from left to right. So, if you look into std : cin, the input operator, then A, it means that A is being read from Cin. What is interesting is, in this format in C++, you can actually put multiple operators, multiple operands, multiple variables, one after the other, as we are showing here. So, after streaming A from the standard input, we again stream B from the standard input. So, this notation means that first A and then variable B will be read from the standard input of the console. We also show how these variables are output to the standard streaming output, which is C out or the std out as in C program. The two major differences that you must note here is, one, we do not need to use the format string in C++. In C, we know if I want to print an integer variable, I need to specify in the format string that the variable is to be printed in %d format, which denotes that it is an integer type of data to be printed. In C++, in contrast, the variable does not need to be specified with a format. The compiler, knowing that it is an integer variable, will automatically decide the format that is required for printing it and will print it in the right way. A second major difference that you should note in between these two programs is, when we do scanf, we are reading values from the stdin, and since in reading that value, the original value of variable A has to be changed to the value that is input by the user, we need to pass the address of A. As you would be familiar in C, this is kind of a call by address mechanism that is being used, where we pass the address of the variable as a call by value parameter to the scanf function. In contrast, in C++, when we are reading from the input stream, we do not need the address to be passed. We can simply specify the variable and the compiler will take care of the rest. When we learn more of the C++ operators and call mechanisms, we will understand how this really works, but it certainly becomes more convenient to get rid of the format string as well as the need to specify either the variable for printf or the address of the variable for scanf. In C++, everything can be done uniformly. There is another small difference that you may note in terms of the declaration of variable sum. In the C program, the variable sum is declared at the top after the variables A and B, because the original C or the old version of C, which is C89, specified that all declarations of variables must happen before the first executable statement in the program. In the C program that we see here, the first executable is the printf function call. So, all variables must be declared before that. In C++, this restriction does not exist. So, we can declare the variable as and when we need them. When we are starting the main, we just need the variables A and B because they need to be read, but when we need to do their sum, at that point we can declare sum as a variable, and then use a plus b and put that result into sum to initialize the value of sum. Of course, this should be noted that later version of C, that is C99, does allow you to defer the declaration of variables to like in C++ to the point when you actually need the variable. So, please carefully read and run these programs at your computer to understand the similarity and the differences better. We will next move on to another program, which is again a simple program using mathematical computation, which I am sure you all have done at some point of time in the C program. So, we know that in C there is a math.h header as a part of the C standard library, which has a number of useful functions. So, here we are just illustrating the use of one such function called sqrt for finding the square root of a double variable. It takes a double variable and returns a double result, which is the square root of the parameter that is passed to sqrt. The similar function can be invoked in C++ as well. So, we are showing how to do that. You please note that the header that we use in C++ now has changed in its name. In C we were calling it math.h. The same header in C++ is called CMath, and we will see that this is a common convention that any C standard library header can be used in C++ as well, but when you use that you add a C at the beginning of the name. This C means that the standard library header is coming from the C standard library, and the other difference is you drop the .h extension to the file name that existed in C, you just call it CMath. Of course, when we do this, as I had mentioned earlier in terms of the names of cout and endl, these also are in the same namespace of std, which means that the function sqrt in C is just called sqrt, whereas in C++ this function name will become sqrt prefixed with std, that is the full name is std : sqrt. Now, here we also show another shortcut or convenient way to express the standard library symbols. Note, after the hash includes in the C++ program, we have written a line saying using namespace std. This means that if we include this line, then any standard library symbol that occurs in the C++ program will be assumed to have std : as a prefix. You will not have to every time write std : cout, std : cin, std : endl or std : sqrt. So, this is a convenient way of doing that. You could either make use of using namespace feature in C++, or if you are not using it, then all standard library symbols will need to be prefixed with std : Rest of the program is very easily understandable, and it is pretty much like the C program that you see on the left, or the changes are according to the input and output streaming, as we have already seen. So, with this we will move on and take a look into the C++ standard library, just summarizing what I have already specified, that in a C standard library all names are global, that is all standard library functions, macros, they are available to any function by the name that they have. So, therefore, all C standard library names are actually, for all practical purposes, get reserved in a way that is, you cannot write a printf function of your own and also continue to use the printf function given in the C standard library, because the moment you write a printf function of your own, that also has a name in the global space. We will understand this more when we study about namespaces formally in C++, but please note that all names are just available in the global space. In contrast, in C++ standard library, all names are in the std namespace. This is specifically reserved for the standard library, this namespace, and all names are prefixed with std::, meaning that the name occurs within this std namespace. So, namespace is like when we use in our own names, it is like a family name or the last name that we use. So, I am Partho Pratim Das. So, Das is my last name and my name is Partho. So, there could be another Partho in some other family name, say Partho Pratim Chakraborty. So, these are distinguished by the different family names that exist. So, namespace is something similar to that. We will talk more about it subsequently. So, we just also illustrate here that if you do the shortcut of using namespace std, then you do not need to prefix all standard library names with that std::, namespace. Now, I would like to highlight something which is very specific about headers of standard library. So, we have noted that C++ is backward compatible to C. What does that mean? It means that any C program should be executable as a C++ program also. This brings in another question, that what do we do with the standard library of C? As I have already illustrated, that standard library of C can also be used in a C++ program. But there is a small point to be noted while you mix the program from C with the program from C++ in terms of how you specify the standard library headers. So, this table show you how you can do this. On the left, on the rows we show the language in which you are writing the program, and on the column we are showing the header being used from which standard library, whether it is from C or it is from C++. So, if you are writing a C program and you are using C standard library headers, we all know you will include like stdio.h. If you are writing a C++ program and including a C standard library header, then as I have mentioned, you will need to prefix the C standard library name with a C. So, stdio.h now becomes C stdio, and you will have to drop the .h from the name, and all of these symbols from the C standard library now gets into the std namespace and will have to be prefixed with std::. If you write a C++ program and include the C++ standard library, you will simply include it as #include IOStream. All standard library headers in C++ do not have any .h in their file extension. This is for a historical reason, which I would try to explain at a later point of time, but please note that IOStream.h should not be included. And the last box in this matrix, that if you are writing a C program and you want to use a C++ header, certainly is not applicable, because you cannot do that. C++ has a lot of features which C does not support, and therefore, such a use cannot be done. Specifically note, and I have highlighted with red, that by mistake or by the practice of using .h as a file name extension for standard library headers in C, if you include IOStream.h in a C++ program, your compiler may not actually give you an error, which means that your compiler is actually dated and you should move to a more recent compiler, and therefore, this is a very dangerous proposition, because you are making a mistake. IOStream.h, or for that matter any C++ standard library header with .h extension file has been, all of them have been deprecated, they are no more in use, but some compilers still continue to allow them, because they were written before all these changes were done in the C++ standard. So, please keep in mind these conventions of standard library headers. Next, we look into the use of loops, which is very similar to what you have in C. So, here we are just adding a set of a sequence of numbers starting from 0 up to n and summing them using a for loop. The same program almost identically will work for C++, except for the differences in the IO headers and the C out streaming convention. You may also note that for the for loop, the loop index I can be declared within the parenthesis of the for construct. If you do that, then this declaration of I is local to this for loop. That is, once you come out of the for loop, you are in the subsequent C out statements or later on, I will not be considered to have been declared. So, this was introduced so that you can just, whenever you need local index variables, you could quickly locally use them and do not have to really think about whether you have declared that variable earlier, whether it has been used in some other context and so on. You can just locally declare them and use them in C++. This was not possible in C 89, but this is now possible in C 99 also. Finally, in the last section of this module, we illustrate the use of the Boolean type. We all know that C has a possible use of a Boolean type, which is a type where we say that it can take a value either true or false. Now, C, which is C 89, the original old C that we have, did not have a separate type for bool. So, what it did is it was using the int to interpret bool, that is, anywhere you want to put a Boolean condition or a Boolean value, you will declare a int variable and set that to 0 if you want to mean false, and set that to something non-zero if you want to mean true. So, out of these 3 columns, if you look at the leftmost column, is the most common way that C programmers had been dealing with the Boolean. You could for convenience define 2 constants, true and false, to be 1 and 0 and use them in your program. But as I show, the int variable to be the variable x to be used for the Boolean condition is declared as of int type and is initialized with true. So, if you print, it will show that it has a value 1. This is what existed in C 89. Subsequently, in C 99, a change has been made to introduce a bool type. Now, before looking into that, let us first look into the rightmost column, which is the C++ program. In C++, you have bool as a built-in type, as you have int, char, float, double. Similarly, you have a bool type. This bool type has only 2 literals, true and false, both in lower case. So, they are keywords now reserved as well. So, if you want to similarly define x for use as a Boolean variable, you can directly use bool, which makes it very easy to understand that you are actually dealing with a Boolean value, and you could initialize it with true or false. But if you try to print the value of this variable, it will not print true or false, it will actually print 1 or 0 if it is 1 if it is true and 0 otherwise. Naturally, being able to use an explicit built-in type bool has a lot of advantages. The most significant of that is, from the C++ program, if you have used bool to specify your Boolean value, anyone else who reads the program will be able to understand that this variable cannot take any other value other than true or false. In contrast, if you use the C style of using int to mean Boolean value, then it can actually take multiple different values which are interpreted as true or false, as the case may be. Now, in the middle column, we see an interesting extension of C programming language. In C99 standard, what C99 came up with, C99 introduced a explicit Boolean type, and that is given by the name underscore bool, where B is written in capital. But that since that is not a very normal natural way to write bool, it has also provided a new standard library header called stdbool.h, where 3 macros are provided. The first macro defines BOOL in lowercase as same as underscore capital BOOL. So, if you use the BOOL in lowercase in a C99 program, then you are actually using that new predefined type underscore capital BOOL, and it also defines true and false as 1 and 0 in the header, so that you could use them as constants here. So, if you are whenever you are using C, now you should always use the bool type and not use int and interpret it as a bool type. In C++, certainly it has come out to be a built-in type. So, we will show that it has several other advantages as well as we go along with the different types. So, in this module, we have tried to understand the basic differences between C and C++, with specific focus to how you perform input output, how you declare variables, and how the standard library of C and C++ are used in C++. And we have started to see that C++ gives us more flexibility in terms of how we can declare and how we can do input output. Now, we do not need to have those complicated printf statements, printf function calls, where the formats are into a separate string, variables are listed separately. We do not need to remember that scanf needs the address of variables and so on. And in this way, many constructs and functions have been simplified in C++, which will help in the increased ease of programming.